Hey guys, welcome back to Math with Morgan. In today's video, we're going to be looking at laws of indices. So the objective of this video is for you to learn the different rules of indices and also how to compute and work with negative and fractional indices. Let's get started. So what you must know for this topic would be what is a base and an index or power. Okay, let's go by example. If we have 5 with a little tiny 2, like this, 5 is called the base, and 2 would be called the power or index. So you can read this number as 5 to the power of 2, or simply 5 squared. Okay, so the numbers 3 squared and 3 to the power of 6 have the same bases, and the base is 3. While the numbers 4 to the power of 5 and 7 to the power of 3 have different bases. Now, to apply the rules I'm about to teach you, you must always make sure that the bases are the same. Okay, let's have a look. We're going to start off with the laws of indices. Let's just say we are given A, B, P, or Q such that all of these A, B, P, and Q belong to the set of real numbers. The following rules apply. Rule number 1. A to the power of 1 should be equal to A. For example, if you have the number 4 and it's raised to the power of 1, that is the same as 4. Rule number 2. A to the power of 0 is the same as 1. For example, if we have 5 to the power of 0, that will be equal to 1, and even 1000 to the power of 0 would still be 1, regardless. Even if you have 1,000,000 to the power of 0, that would still be 1. Rule number 3. A to the power P times A to the power Q is equal to A to the power P plus Q. So what does this mean? When you have the same bases multiplying each other, what do? You add the powers up. For example, if you have 4 cubed times 4 squared, this will be equal to 4 to the power of 3 plus 2, and the answer will be 4 to the power of 5. The explanation would be, you can have 4 cubed, but then 4 cubed is the same as 4 times 4 times 4, and 4 squared is the same as 4 times 4, which is equal to 4 to the power of 5. Now, the 5 there represents the number of 4s that you can actually count. Over there, I can count 5 4s, so that means this is the same as 4 to the power of 5. The next rule, we have A to the power of P divided by A to the power of Q equal to A to the power P minus Q. And here we have an example. If you have 9 to the power of 7 and 9 to the power of 3, you just take away 7 and 3 and you get your answer. But then why so? Let's say we have 9 to the power of 7 and 9 to the power of 3. 9 to the power of 7 means we need to write 7 9s, and then 9 to the power of 3 means we need to write 3 9s. So when we're dividing these numbers, each of the 9s can cancel up. Since we have 3 9s at the denominator, it can cancel out with 3 of the 9s in the numerator. So we're going to be left with just 4 9s, so that would just be 9 to the power of 4. Alright then. The next rule would be A to the power of P or raised to the power of Q equals to A to the power of P times Q, which means that if you have a number having a power, but then that number is still raised to another power, you have to just multiply the powers all together. So for example, you have 12 to the power of 3 raised to the power of 5. You can see here we just multiplied 3 and the 5 all together. The next rule is if you have two different numbers, A and B, raised to the same power P, what you do is you simply separate those numbers, A, and give each of them the same power. So it's going to be A to the power P times B to the power P. For example, if you have 5 times 7 raised to the power 3, this is equivalent to 5 cubed times 7 cubed, which is 125 times 343. Okay, now we have the tricky rules, which are negative powers. Let's start off with this one. If you have a negative power, such as A raised to the power negative P, what you do is basically invert it. So you're going to have 1 over a to the power p, but just make sure that you put a positive power whenever you invert it. Let's look at an example. 6 to the power negative 1 is equal to 1 over 6 to the power positive 1, which is 1 over 6. Now, 1 over 6 is also known as the reciprocal of 6. Okay, so 1 over 6 is equal to the reciprocal of 6. But if we take a look at this example here, where we have 8 to the power negative 5, you see we're just basically going to invert the 8 to the power 5 and put 1 over it. But keep in mind that we make sure that the 5 is positive. Okay, the next tricky rule has to do with fractional powers. If you have a to the power 1 over p, what do? You simply have to get the root of that number, the p root of that number. For example, if you have 16 to the power half, what do? You just get the square root of 16, which is just 4. Another example is if you have 27 to the power 1/3, you get the cube root of 27, which is just 3. Now, the last tricky rule would be two-stage fractional powers. Okay, in this case, you have p over q. Those are two different numbers, but always make sure you get the q root of the number. I'm just going to explain this with an example, okay? So if you want to work out 81 to the power 3 over 4, right, we need to get the 4th root of 81, and then we cube it, okay? So in this case, the 4th root of 81 is 3, and when we cube 3, we're going to get 27. Hope that's much better understood. Let's have a look at some worked examples right here. So we're going to simplify m to the power minus 2 raised to the power 5. Remember the rule, if a number has a power but then it's still raised to another power, what do? You just multiply both powers. And in this case, the answer will be m to the power minus 10. But you can simplify that further using the negative power rule by inverting it and having 1 over m to the power 10. Okay, the second example, if we have x to the power 10 divided by x to the power 4, the bases are the same, so we can apply the rule. Whenever we're dividing and the bases are the same, we just simply subtract the powers. So this will be x to the power 10 minus 4, and the answer will be x to the power 6. Okay, second example, we want to simplify 5u squared w to the power 4 times 7u w cubed. Okay, this one's a bit tricky. What we'll have to do is this. We're going to bring the like terms together, okay? Wherever you have u's, you just make sure you bring them together. And also consider the powers. So, we'll start off by doing 5 times 7, and then u squared times u, then w to the power 4 times w to the power of 3. Okay, so you see that each of the terms, the like terms, are in the same position. This is going to give us 35 u to the power 2 plus 1 and w to the power 4 plus 3. Sorry, that's supposed to be a w. Okay, we're adding the powers simply because both indices were multiplying each other, okay? So when we add the powers, we're going to get our answer 35 u cubed w to the power of 7. Example number 3. Write these numbers in order of size in ascending order. Okay, so we have these numbers here, but some of them are in index form. So we have to write them as normal numbers first. 5 to the power of minus 1 is going to be 1/5. 0.5 is a half, negative 5 stays the same, and 5 to the power of 0 is 1. Remember, anything to the power of 0 would always be 1. Now we can rearrange this. Well, the negative number has to come first because that will be the smallest one. And then you're going to have to convert each of these numbers to decimals because that will be easier to work with. 1/5, I believe, can be written as 0.2. and half can be written as 0.5. So if we're going in ascending order, -5 comes first, 0.2 comes next, 0.5, and then 1. That will be our answer. Okay, example 4, simplify 9x to the power 8y cubed all raised to the power half. Okay, so whenever we have different terms but raised to the same power, what do? We just separate those terms but still raise them to that power. So we're going to have 9 to the power of half, x to the power of 8 but still raised to the power of half, and then y to the power of 3 but still raised to the power of half. Okay, now we go ahead to multiply each of these powers. So for the number 9 to the power half, well, that's quite easy. It's going to be the square root of 9 that we're talking about. Then when we multiply 8 times half, we get 4. So x will be raised to the power of 4, and then y will be raised to the power of 3 over 2. Okay, the square root of 9 is 3. So we're going to have 3x to the power of 4, y to the power of 3 over 2. That could be your answer, or you can have the answer on the right, 3x to the power of 4 square root of y cubed. All right then. The next set of example, we have to simplify 32 q to the power 9 r to the power 4 divided by 4 q cubed r. Okay, we're dividing here. So what I always like to say is separate each of these into like terms. So you're going to arrange the q's together, the r's together, and then the 32 and the 4, because those are just numbers. So what you do is this: you have 34 divided by 2 on its own, q to the power 9 divided by q to the power 3 on its own, and r to the power 4 and r to the power 1 on its own. And that's easier for you to see what you're working with. So 32 divided by 4, that would just be 8. But then keep in mind that since we're dividing the q's here, you're going to have to subtract the power. So you do 9 minus 3, which is 6. And the same thing goes for r. So you do 4 minus 1, which is 3. Okay, your answer would just be 8q to the power 6 times r to the power of 3. Simplify and work out the value of n in the equation. Okay, here's the equation. So what do we notice first? All of the numbers have the same basis, which is 2, 2, and 2, okay? On the right-hand side, we have 2 to the power of 9. On the left-hand side, we have 2 to the power of 3 times 2 to the power of n. We are multiplying those indices with the same basis, so we have to add their powers up, okay? So in that case, we'll have to do 2 to the power 3 plus n equal to 2 to the power 9. But then keep in mind, since both of them are the same basis, it means their powers will also be equal. So we do 3 plus n equal to 9, and we work out the value of n by subtracting 3 on both sides, and then we get n equal to 6. Okay, so this question is a tad bit different because it requires an extra step. In the previous questions, we have had the same basis, but then in this one, we have to change all the numbers to have the same basis in order to be able to apply the rule of indices. Okay, 16 can be written as 2 to the power of 4. Okay, and to get that, you need to know how to prime factorize. I did my previous video on prime factorization, and I'm just going to leave the link down in the comment section or in the description. Okay, so 16 can be written as 2 to the power of 4 times 1/5. Then we have 2 to the power of x, and on the right hand side, 8 can be written as 2 to the power of 3. So we multiply 3 by 3/4. Now, what we're going to get is 2 to the power of 4/5 times 2 to the power of x equals 2 to the power 9 over 4. Since the bases are the same, we're going to add 4/5 to x on the left hand side, and on the right hand side we're going to have 9/5. And then since the bases still are the same, we're going to equate their powers up. So we have 4/5 plus x equal to 9/4. And then finally we find x. by simply subtracting 4/5 on both sides. And to do that, you must know how to work with fractions. I'm not going to teach you that in this video, but if you want to, you can leave a request in the comment section. So x will be 29 over 20. The next example here, example 8, says find the value of 8 divided by 125 or raised to the power negative 2/3. So we have a negative power over here, okay? The first thing we want to do is make that power positive by inverting this number. So we're going to take 1 over this number. It's going to be 1 over 8 over 125 all raised to the power positive 2/3. But then these are fractional indices. So here's what we're going to do. We have to find the cube root of 8 over 125 because 3 is in the denominator of the power, okay? So we're going to find the cube root of the number first, just like this. The cube root of 8 is going to be 2, and the cube root of 125 is going to be 5. So we're going to have 1 over 2/5 to the power 2. And that's going to be 1 over, oh, that's supposed to be 25. So we're going to have 1 over 4 over 25. And then when we have 1 over a fraction, what we need to do to get the answer is just to flip the fraction over, because it's basically the same as 1 divided by 4 over 25, which is the same as 1 times 25 over 4, and our answer is going to be 25. And our answer is just going to be 25 over 4. Okay, pardon me for this last one. I think I made a mistake in this question. I just wanted you to see the different formats in which questions can come so that you know how to work with them. But then if you found this video helpful, just give me a thumbs up and I'll see you in my next one.